Hi everyone, my name is Rachel Rymaszewski. I'm an intern here at the Sustainability Institute, and today I will be talking about UNH's local nitrogen footprint. So first I will begin by discussing what a local nitrogen footprint is. I will later define UNH's local nitrogen footprint specifically, and then conclude with some example scenarios. So the Great Bay Estuary is located in the Gulf of Maine watershed near the Durham UNH campus and has a number of rivers connected to it throughout eastern New Hampshire. However, the Great Bay currently suffers from a large nitrogen problem. For instance, it has very high levels of dissolved inorganic nitrogen, and we have also seen a 64% decrease in eelgrass biomass within a 20-year time span. So UNH is looking to determine what impact that we may have to our local community. And UNH is also the first university to develop this type of methodology. So taking a step back, what is a nitrogen footprint? It is the amount of reactive nitrogen released to the environment as a result of an entity's resource consumption. The two main drivers to this include food consumption and production, as well as energy. And as you can see here, all of the local nitrogen footprint categories pertain to energy. And from a 2014 baseline, this encompasses about 19% of the total nitrogen footprint. So we are measuring the local nitrogen footprint at two levels, the first one being at the watershed level. So a watershed is all of the land that drains into a body of water. We are interested in calculating the total emissions across the drainage basin our university is located in. So the different activities that we are accounting for include mobile combustion, fertilizer in animals, stationary fuels, as well as wastewater. And so as we know, all of these activities emit nitrogen. Some of the reactive nitrogen that was released within the watershed gets attenuated through the soil, or it gets blown out of the watershed before it even makes its way to the river or the bay. So that is why the second level to our local nitrogen footprint will be measured at the Great Bay level. So we are interested in seeing what fraction of nitrogen is going to make its way from the watershed to the Great Bay. So there are a few steps in order to define our local nitrogen footprint goal. So I already discussed the first one, which is calculating the footprint at those two levels, the watershed and Great Bay. From there, we are able to assess reduction scenarios. UNH has been collaborating with the Ecosystem Task Force on campus, who examine sustainability issues related to land use, development, and ecosystem management. And so we are then able to compare those scenarios that are feasible with local pollution reduction initiatives that may already be ongoing on campus or in our local community. And from there, we can define our local nitrogen footprint goal. So here are two lists of potential scenarios. The first one here has been in collaboration with the Ecosystem Task Force. So some examples include converting fleet vehicles to renewable sources, decreasing our fertilizer use, replacing fertilizer with compost or manure, and reducing commuter emissions. And the second list here has been in conjunction with WildCat, which is the Wildcat Climate Action Plan, where UNH has agreed to reduce 80% of our greenhouse gas emissions by 2050. And so some of these examples include energy conservation, as well as more renewable energy sources. On the left here is the watershed footprint baseline from 2014, which is about 19% of the total nitrogen footprint. And on the right here is the Great Bay baseline, which is about 9% of the total nitrogen footprint. And if we were to apply those scenarios, which I previously listed, or any other feasible scenarios, we would see a decrease in our impact to the local community, and we would also have positive implications on both air and water quality. So in conclusion, the goal of a local nitrogen footprint is to evaluate our impact to our local community from a nitrogen standpoint. UNH is currently finalizing the methodology for this footprint, and we could improve local environmental quality with those identified scenarios or any other feasible scenarios as well. And I just want to say thank you to everyone who has helped to work on the calculations and the methodology for this footprint. So, thank you.